Good morning to everyone. A lot of people today I have decided to start my lecture series, and lot of people ask us that what are the glazes in whiteware industries, what is the role of raw materials in glazes, how do we solve the defects problems in glazes. So that's why I have chosen today as a first part that what are the glazes and what is the actually glazing process. So for that I will start that ceramic glazes really are a thin glassy coatings. That glassy coating get fused on the surface of the ware when it is applied and heated. And if we say that what is glaze, it is impervious, it is strong, it is, if you say that water absorption is almost 0%, it is, we can easily clean it, it is chemically inert, and this gives good touch, pleasing touch, attractive designs on the wares, and we feel it. But our eye likes those glazes. Now, if we go means what is the properties we require for the glazes? It should get fused with the body, and fusion on the surface it is like glass. It should get fused, and it has some fusing that glassy materials. We have B2O3, we have P2O5, we have silica, we have alumina, chromium oxide, iron oxide, we have calcite, titania, zirconia, we have tin oxide, we have zinc oxide, we have magnesium oxide. These are used for different raw materials are used to get the desired properties in the glaze. The complex mixture we talk, then that all these different raw materials provides a different complex mixing and mixture, and that's why we decide the temperature of the glaze. Then very important factor is that when we heat the glaze should be able to flow on the surface of the ware, and it should not overflow, and it should not have very low flow. So at that firing temperature, then only it will give us a impervious surface, glassy coating on the ware. So viscosity of the glaze at firing temperature is a very important property, and it governs the success of several process controls carried out at different temperatures. Viscosity is the only property which determines the easy escape of gas bubbles during firing reactions. It decreases with the increase of temperature. Then for this purpose we in India we add, so means Na2O, K2O, we add silica, we add alumina based raw materials, we have zirconia based this thing we say opacifier. All these raw materials increase the viscosity of the glaze. Where lithium oxide, which is not available in India, generally is found in China, and it is used in China, whereas we use potash feldspar for this as a source for potassium oxide. Then another thing is chemical resistance. Glazes are very more resistant to acids than alkalis. Alkaline oxides like potash and potash feldspar, soda feldspar, all these decreases the acid resistance. Alkaline earth oxides improves acid resistance. Opacifier as titania, zirconia, tin oxide, they improve acid resistance property and decreases alkali resistance property. Alumina, if we use in the glaze, increases the wear resistant property as well as alkali resistant property. And when we go talk about, because the wear surface and glaze will coat the surface, so that both will have, when glaze will flow, it will have surface tension. So surface tension should be low to avoid crawling of the glaze. Flow of the glaze also get influenced by the surface tension. Low surface tension favors elimination of gas bubbles. High surface tension favors reabsorption of the bubble during cooling of glaze. That's why we get pinholes. So high surface tension is responsible that bubbles, pinholes, and if its surface tension is too low, then it favors the run of the glaze from the body. Sometimes people complain that body is visible and glaze has disappeared from maybe 2-3 mm, 5 mm surface of the body. Additive factors. So we have lithium, we have soda, potash, magnesia, all these things, raw materials, zinc oxide, lead oxide, although lead oxide is not preferred in the glaze. So all these raw materials help in our surface tension control and balancing the surface tension. Then when we use the glaze and when we heat it and when we reach to the peak temperature, then glaze should not volatilize at that peak temperature. So volatilizing materials like lead oxide, soda ash are not good for this thing. So we should avoid these raw materials to avoid volatilization. Volatilized material should be used in glaze after fritting. When we use fritted material, then we can use this. Volatilization affects the furnace as well as surface finish of the product. If volatilization is high, that volatilized material gets deposited to the furnace, that fiber also. The life of the furnace goes down. Then it reacts with glaze will react with the body. The interaction between the glaze and body surface is essential so that both are sticking to each other, and interaction is very important, and interaction zone between body and glaze forms the bonding. It should be moderate. Sometimes due to migrated salt, sometimes its body is having more salt, that will affect the reaction with the body. Glaze fails to get an adequate grip on the body. So then we have the defects like crawling, chipping, etc. occurs. Absorption of the glaze, suppose into the body during firing, should not occur. To avoid absorption, the body should be non-porous. The flow of the glaze should also be moderate. So it means glaze should not be absorbed by the body. Glaze should flow over the body, and glaze should give good appearance, look on the body. Sometimes we face the devitrification of the glaze. Devitrification should not occur. Vitrification means that zero porosity. But then when devitrification occurs, then slow it occurs. So slow cooling is the main reason for devitrification of the body. And some we nowadays it has become a this thing surface designing like that. People say it is crackle glaze. So when glaze will crack on the surface of the body, so that devitrification is the reason. So glaze composition should be changed if devitrification is taking place, or cooling should be controlled. Rate of cooling of the wear should be controlled. Then another thing we face that creating problems in the glaze. So thermal expansion of the glaze and Young's modulus of elasticity of the glaze are controlled. So if suppose both the properties of the glaze as well as of the body should be controlled and should be in same range. So these are two means physical properties, basic properties of the glaze and body, and we call it that glaze fit properties. So too much difference between the thermal expansion and between this Young's modulus will give us glaze defects. So crazing will start, and so this misfit of the glaze, the misfit of the thermal expansion, glaze is not fit, then this glaze will crack on the surface. This problem starts. We should look for the stress curves for various earthenware glazes. Homogeneity is important. Glaze should be smooth. It should be hard. It should be abrasion resistant. It should be scratching resistant. And if we measure the hardness of the glaze, so we should see that we use the methods: elastic deformation, what is the tensile strength of the glaze, what is the impact resistance of the wear, means of the glaze, what is the scratch resistance of the glaze. We also measure the properties like mechanical strength, we measure the thermal expansion of the glaze. So if means mechanical strength, if we say, it increases if glaze is under compression. We measure that reflectance of the wear, whiteness of the glaze, what is the reflection of the light from the glaze. These are optical properties. And we measure the transparency of the glaze. So when the glaze is totally fused, then we say yes, and it is transparent. Then we may see how is the reflection. Opacity is due to solid and gaseous crystals during firing. That is opacity. We get matte surface, matte glaze if we increase silica, alumina, zinc oxide and barium oxide in the glaze. If we all these glazes, another means all the properties are important. We measure the chemical stability, durability of the glaze. So when chemical properties of the glaze should be different for different ceramic wares. So after glazing artware or other articles, then after glazing it becomes chemically inert. We add colors to the glaze. Color of glaze affecting by the coloring agents, what color we are adding, what is the composition of the glaze. We should have that calculations of alumina, silica, all borate, all those glass forming oxides. We should see the kiln atmosphere also will change the color of the glaze. If it is oxidizing or it is reducing, it is insufficient oxygen. Sorry. Firing temperature also plays major role for how is the glaze shining, otherwise not shining. So today I have covered what about this, what is the glaze and what are the oxides, what are the defects, what are the properties, and this in this part 1 I have covered all this, and next immediately I will talk about part 2, where I will talk what are the raw materials for the glaze and what raw materials and what is the means role of each raw material in the glaze and how we can control the defects in the glaze. So with this, my talk is ends here, and I thank you all for listening. It is, I think you will like it. It is informative session, and continuously I will be doing it. I request you all to subscribe my channel, and I will be talking on different topics, and I will be posting different videos. I travel a lot here and there, and we are setting up plants of terracotta as well as advanced ceramics and even refractory plants, not only in India, as we are working on abroad also. So I thank you once again. Thank you very much.